Hello students, in today's lecture we are going to discuss about the limitations of dimensional analysis. So we know that dimensional analysis it is very useful to us. By using the dimensional analysis we can check the truthness of a given physical equation. We can establish the relationship between different related physical quantities. Also we can determine the conversion factor, but with these uses there are certain limitations of dimensional analysis also. So what are those limitations? So the first limitation for the dimensional analysis is that, so for that purpose we are going through the example, that is f equals to capital G, that is capital M into small m upon that is the r square. We know that this is the very famous relation that was given by the Newton, or we can say that this is according to the Newton's law of gravitation. And in this equation this capital G, it is the constant of proportionality. This is the constant of that is proportionality. So the first limitation it is regarding to this constant of proportionality. We can use the dimensional analysis for those relations which contains the constant of proportionality, but that must be the dimensionless quantity. We know that this G, it is having the formula that is G equals to that is F r square upon that is capital M into small m, and this G, it is having the dimensions also. It is not the dimensionless quantity. So for the dimensional analysis, to use the dimensional analysis, this constant of proportionality that must be the dimensionless quantity. So the first limitation, that is constant of that is proportionality, constant of proportionality that must be that is the dimensionless that is the quantity. If the constant of proportionality it is the dimensionless quantity, then we can use the dimensional analysis, otherwise can't use the dimensional analysis. So it is the first limitation regarding the constant of proportionality. Then the second limitation of use of dimensional analysis, regarding the use of dimensional analysis, it is that this constant of proportionality or the value of constant of proportionality, we are again going through the example, that is kinetic energy. We know the relation for kinetic energy, that is kinetic energy equals to K m into V square, and in this equation the value for this constant of proportionality that is half, and therefore we can write like this: kinetic energy equals to half mv square. So this value for constant of proportionality that can be calculated by using the experiments only. That means by using the dimensional analysis we cannot find out the value of constant of proportionality. This value that can be find out by using the experiments only. So the value of that is constant of proportionality, it is find out by using experiments only. Experiments, that is the only. So by using the experiments we can find out the value, and by using the dimensional analysis we can't find out the value of constant of proportionality. So this is the second limitation regarding the use of dimensional analysis. Then the next limitation regarding the use of dimensional analysis is that Again we are going through the example, that is s equals to ut plus, that is the half at square. This is the second equation of, that is the motion. So in this equation ut plus half at square, these are the two terms. But if we write like this, that is s equals to half at square, then these both equations are dimensionally correct. If we compare the dimensions, then you can say that these two equations are dimensionally correct. But we know that this is the correct one, this is the correct equation, this is the correct equation. So if we make the dimensional analysis, then we can observe that both the equations are dimensionally correct. So what is the limitation? Then we can say that if the given equation contains more terms, then we cannot find out the terms, more terms present in the given equation by using the dimensional analysis. So more terms, if the equation consists of more terms, then more terms can't find out by using the dimensional analysis. So the presence of more terms cannot be find out by using the dimensional analysis. So it is the limitation regarding the use of dimensional analysis. And if the given equation that contains, that is the logarithmic functions, or the given equation that contains the exponentials or trigonometric functions, then this dimensional analysis, it is not useful for that equation that contains the logarithmic functions or the exponentials or the trigonometric functions, because all these are, that is the dimensionless, that is the quantities. And so these are the limitations regarding the use of, that is the dimensional analysis. Thank you.